Hello everyone, this is Mr. Appel, and today we're going to learn about proving that lines are parallel. Now you see a whole lot of words on your screen, but a lot of these you should already have written in your notes. This whole top area up here from the previous lesson are the 5 different theorems that we talked about, postulates and theorems, about when two lines are parallel, what you know. So these theorems down here, postulates and theorems down in this area, are simply the converse of the 5 up here. So the converse, remember, is just the reverse order. Same thing in the reverse order. So for example, the parallel postulate says if the lines are cut by a transversal, then corresponding angles are congruent. Now we're going to say the converse of that, which is if the lines are cut by a transversal such that the corresponding angles are congruent, then the lines must be parallel. And it gets very wordy that way, so I'm going to show you the sort of shorthand version like we did in class with the first 5. You can simply say, if corresponding angles are congruent, then the lines are parallel. But the key is, in this case, you don't know that the lines are parallel. You do know that corresponding angles are congruent. So similarly with the others, if the alternate interior angles are congruent, then the lines are parallel. If alternate exterior congruent, lines are parallel, and so on. Same side sup, yo yo yo, same side sup. So if same side sup, then the lines must be parallel, and if same side exterior are supplementary, then the lines are parallel. So if you know any of these things over here, then you know that the lines are parallel. If you haven't already done so, you should pause and write those theorems down. Now let's look at some examples of how you can apply those theorems. So here we have a funny looking diagram with some bunch of intersecting lines and a bunch of angles formed. So here I'm going to give you some information, and you're going to need to deduce whether or not you can prove any of the lines are parallel based on that information. And I'm going to show you what that looks like. So for example, this first one, number 1, says that angle 1 is congruent to angle 4. So if I look at the figure and I say, okay, angle 1, and I'm going to trace it, and I really recommend doing this, is congruent to angle 4. By the way, if you haven't already done so, you should pause and copy that figure down so you can do this along with me. So if angle 1 and angle 4 are congruent, what can we deduce? Well, what we're looking for is, are angle 1 and 4 formed by 2 lines in a transversal, and are they one of those 5 things? Are they corresponding angles that are congruent? Are they same side sup? Are they any of those things? So the easiest thing to do is trace the angles and then just extend the sides of the angle. So angle 1, I'm going to extend that side and then extend this side all the way across my figure. And then I'm also going to do the same thing for angle 4. So there's this side extended. And notice that when I extend the sides of those 2 angles, I have a parallel line, another parallel line cut by a transversal, and we have those 2 angles, which if you haven't already noticed, those are corresponding angles. So if the corresponding angles are congruent, then the lines must be parallel. So the question then is, which 2 lines? Well, you can see it's line L and line T. So we could deduce from this that line L is parallel to line T. Let's look at another example. So let's look at number 2. Angle 6 congruent to angle 4. So I'm just going to trace out angle 6 and then trace out angle 4. And then I'm going to extend the side. So there's angle 6 extended, and then angle 4 extended. And I'm just going to highlight, there's 4 and there's 6. So hopefully you can see that those are alternate interior angles and they are congruent. Therefore, lines J and K are parallel. So we could deduce that J must be parallel to K. Now this next one's a little tricky because you might be wondering, what's 2 plus 3 congruent to 5 mean? Well, little angle addition here. If we take angle 2 plus angle 3, what angle do they make together? Well, they make this angle. And if that angle, those 2 combined, is congruent to angle 5, then what do we have? And hopefully without tracing it you can see, drum roll, we have corresponding angles. But if you're having trouble seeing it, again, I really recommend trace those angles out. So there's 2 and 3, and we're looking at that whole angle together, the two together, combined with angle 5, and you should see that we have corresponding angles congruent. What are the two lines? Not the transversal, but the two lines. The two lines are L and T. So L parallel to T. And finally, we see number 4, 2 plus 3 plus 8 congruent to 180. Of course, those should say measures of are equal to 180, so you can write that down correctly in your notes. But if you see that 2 plus 3, again we see 2 plus 3 plus 8 add up to 180. So this angle plus those angles add up to 180. Then we're going to end up with some supplementary angles. So if I extend the sides of angle 8 and then extend the sides of the 2 and 3 combined together, that's where this gets a little tricky. I've got same side interior angles supplementary because they all add up to 180. So 2 and 3 combined together add up to 180. Plus the 8, I'm sorry, add up to 180. So J and K are parallel, so we could deduce that J is parallel to K.